The story of fiber optics begins with a simple idea. That idea was guiding light. In the 1840s, Daniel Colladon and Jacques Babinet showed light could be bent. They used jets of water to show this. Light followed the curve of the flowing water. This principle is called total internal reflection. For many years it remained a scientific curiosity with few practical uses. In the 1920s, John Logie Baird and Clarence Hansel experimented with guiding images. However, the glass was too impure and absorbed too much light. The big breakthrough came in the 1960s at Standard Telecommunication Laboratories. Charles K. Cow and George Hockham proposed a bold idea. They calculated that pure glass could carry light for miles without significant loss. In 1970, a team at Corning Glass Works achieved what Cow had proposed. Robert Maurer, Donald Keck, and Peter Schultz created the first low-loss optical fiber. Using fused silica, they created fiber far better than anything before. Finally, the world had a practical way to send information at the speed of light. The age of fiber optic communication was ready to begin. This innovation significantly improved communication technology and laid the groundwork for modern telecommunications. After the invention in 1970, it took time for fiber optics to be deployed. Telephone companies were the first to adopt this new technology. They saw its potential to carry more calls than old copper wires. In 1977, AT&T and GTE installed the first live telephone traffic through fiber optic cables in Chicago and Boston. These early systems proved the technology worked in the real world. They were expensive, but offered incredible capacity. TAT-8, the first transatlantic fiber optic cable, went into service in 1988, carrying 40,000 calls at once. As more cables were laid, a global network of light began to form. This infrastructure was crucial as the internet was emerging. The internet needed to move large amounts of data quickly between continents. Fiber optics provided the perfect solution. The commercial internet's rise in the 1990s was directly enabled by this backbone. Dial-up modems connected homes over old phone lines. But the core of the internet ran on light. Every email, website, and downloaded file traveled through these glass threads. Without fiber's capacity, the internet would have been slow and congested. Fiber optics let the internet evolve from text to multimedia. The speed we enjoy today is a direct result of that groundwork. For 50 years, solid-core fiber optic cable has been the king of high-speed data transmission. Light travels through a solid glass core, zigzagging and bouncing inside. While incredibly fast, light travels about 30% slower in glass than in air. This delay can be critical for high-frequency trading and future robotics. Now, a new technology is emerging: hollow core fiber, sometimes called hollow core glass straw cables. Instead of solid glass, they have a hollow channel of air or vacuum in the center. The light travels through this empty space. It is guided by a honeycomb-like structure that acts like a photonic cage. The biggest difference is speed. Light moves at nearly its true speed, approximately 99.7% of the speed of light in vacuum. This makes it about 1/3 faster than solid core fiber. For a financial trader sending an order from New York to London, that saved microsecond could be worth millions. It also allows higher power laser signals without damaging the cable. However, each cable type has its own pros and cons. Standard fiber is mature, reliable, and relatively inexpensive. Hollow core fiber is very expensive and difficult to manufacture. It can be more susceptible to signal loss when bent, making installation challenging. It is cutting-edge technology still in early deployment stages. The connection from the global internet to our devices is often wireless. In 2013, Wi-Fi 5, also known as 802.11 AC, became common. It operated on the 5 GHz band, less crowded than 2.4 GHz. This meant less interference from microwaves and cordless phones. It could send data to multiple devices simultaneously, making networks more efficient. Wi-Fi 6, or 802.11ax, arrived around 2019. Its goal was better performance in crowded environments like airports and stadiums. Wi-Fi 6 uses OFDMA technology borrowed from cellular networks, like a delivery truck dropping packages to many houses in one trip. Then came Wi-Fi 7, 802.11b, appearing in devices around 2024. Wi-Fi 7 maximizes speed and minimizes lag. It uses wider data channels, doubling Wi-Fi 6's potential bandwidth. Multi-link operation allows devices to use multiple frequency bands simultaneously. If one band has interference, the other keeps the connection stable. This makes connections reliable for 4K streaming and cloud gaming. Looking ahead, Wi-Fi 8, 802.11b, aims to integrate artificial intelligence. It will intelligently coordinate connections and predict congestion. Each generation improves how devices connect, making wireless fidelity faster and more reliable. The journey from the first flickering light in a water jet to today's global network is remarkable. Fiber optic technology formed the bedrock of the modern internet. It created a superhighway capable of carrying unimaginable amounts of data across oceans. This backbone made the digital revolution possible. Without the ability to move information at light speed through pure glass, our online world would be a shadow of itself. Every video call, cloud document, and streaming movie relies on this invisible web of light. This web circles the globe. Hollow core fibers represent the next leap forward. By allowing light to travel through air, they shatter previous speed limits. This promises to reduce latency to its absolute physical minimum. For financial markets, remote surgery, and autonomous vehicles, this is game-changing. While expensive, the path is clear for hollow core fiber deployment. Wi-Fi evolution ensures these speeds reach our devices efficiently. Wi-Fi 8's AI-managed networks will distribute massive bandwidth flawlessly to dozens of devices we use every day. Together, these technologies craft a future of near-instantaneous global communication, enabling innovations we can only imagine: immersive virtual realities and connected smart infrastructure. The story of our connected world has always been about light, and now with air, its next chapter will be the most exciting yet.